Hello, hello. Today we're going to move on and we're going to talk about Unit 2, Lesson 12 and 13 because they both deal with positive and negative numbers. So let's go through this. On page 112, we are understanding positive and negative numbers. So let's think through. What are positive and negative numbers? Well, positive numbers are greater than 0 and they're located to the right on a number line. So the further right you go, the more positive you get. Negative numbers are less than 0 and they're located to the left of 0 on a number line. Okay, so then we have these here. So the further left you go, the more negative you are. Then you have your 0, which is right in the middle. 0 is not positive, nor is it negative. It is its own thing. So positive and negative numbers are sometimes called signed numbers. Basically, it's just saying that there's going to be a sign in front of it. So positive numbers can be written with or without a plus sign. If you see a number without a sign in front of it, you would just say it is a positive number. Negative numbers are always written with a negative sign. So if you see a negative sign in front of a number, it is a negative number. When solving problems with positive and negative numbers, it's important to think about how far from 0 the number is and in what direction. We're going to be looking at that a lot over these next couple lessons, okay? Looking at how far away a number is from 0. That is a key thing when you are going to be explaining positives and negatives. Alright, so a thermometer shows positive and negative numbers. Okay, the higher the number on the thermometer, the warmer it is. The lower it is the colder. So it says temperatures above 0 are positive. Temperatures below 0 are negative. So once again, your 0, here is our Celsius 0, and here is our Fahrenheit 0, is the neutral point. It's your not positive or negative point. So we need to look at the thermometer. It says 20 degrees is 20 degrees above 0. So if we look, our 20 degrees is right here for Celsius, and it's right here for Fahrenheit. It is above 0. It is 20 above 0. Negative 20 is 20 degrees below 0. So here we're doing the opposite. It's 20 below 0. That means it's 20 degrees from 0 to the negative side. Same thing. Negative 30 is 30 degrees below 0, and 30 degrees Celsius is 30 degrees above 0. So it says to circle the negative numbers labeled on the thermometer. So here I'll change colors again. And starting with negative numbers, we would circle everything below the 0. So that would be these down here. So let's think. Every positive and negative number has an opposite. Numbers that are the same distance from 0 but in opposite directions are called opposites. Okay, every whole number, fraction, and decimal has an opposite. The opposite of 4 would be negative 4. Because both numbers are the same distance from 0 in opposite directions. So here's our 0 point. Negative 4 is 4 away from 0 to the left. Positive 4 is 4 spaces from the 0 to the right. Okay? So, same distance from 0 in opposite directions. To plot a point at 4, you would count 4 units to the right of 0 and draw a point. To plot a point at negative 4, you would count 4 units to the left of 0 and draw a point. And you can see they did that here. So think about folding the number line in half so that the fold goes through 0. Numbers that line up are opposites. All the whole numbers and their opposites are called integers. All of the numbers labeled on the number line above are integers. So you can see here, these are all integers. Basically, it's your positive and negative whole numbers. So let's reflect. Think about the numbers 210 and 10. How could you describe these numbers? what is the same and what is different about these numbers? Well, if we look at them, do they have a sign in front of them? If they don't have a sign in front of them, that means we consider them positive numbers. So we can say that they are both positive numbers. Okay. For differences, we can look at them. 210 and 10. Let's compare how far away from 0 they are. So if we were to look at this, 10 is only 10 places above 0. But if we look at 210, 210 is 210 spaces above 0. So our difference is that 210 is a lot bigger than 10. So I want you guys to look at one more dealing with the same thing. What if we had -8 and 8? What is the same about these and what is different about these? Well, we can say that they are what? Opposites. Good. Okay, they are opposites because they are both 8 away from 0. They are the same. They are different because one is positive and one is negative. Alright, so we're going to explore this idea a little more. It says Jana and a friend are playing a game that shows a number line from -7 to 7. The game is played with 15 cards numbered with the integers from -7 to 7. Players draw a card from a pile. They earn points for correctly locating the number on the card on the number line and then identifying its opposite. So, number 2 says, finish labeling the number lines. So, if we're looking at this and we have 0, we're going to go to the right in order. So, 1, 2, 3, 4, 5, 6, and 7. And then to go to the left, we would do the same thing starting next to the 0. So we'd have -1, -2, -3, -4, -5, -6. Suppose Jana draws a card that shows -3. Draw a point at -3 on the number line. So now we just look at our numbers. We can see -3 is here. It is to the left of 0, 3 spaces, so we draw our point. What number is the opposite of -3? Remember, we talked about opposites on the previous page. It's the same distance from 0, but on the opposite direction. So, -3 would be 3 to the left, so 3 to the right would be a +3. And you can put the plus sign in front of it or not. So, explain our reasoning. Because it is 3 to the right of 0. So, number 5 says, Jana's friend draws a card that shows a 0. Draw a point at 0. What is the opposite of 0? Well, here's our 0 on the number line, so we draw our point. What is the opposite of 0? Well, like I said on the previous page, the opposite of 0 would just be 0. It doesn't have an opposite, it's just its own opposite. So we're going to say it is its own opposite. So number 6 says, the next card drawn is -6. How far from 0 is 6 and in which direction? Well, If we start at -6, that's here. So I'm going to count. It's 1, 2, 3, 4, 5, 6 spaces from 0. And then in which direction? To the left. Draw a point at -6. So I've circled it. Now we just put our point there. So number 7 says, what number is the same distance from 0 as -6, but in the other direction? So if we counted 6 to the right, it would tell us that it is 6 or +6. Number 8, two numbers that are the same distance from 0, but on different sides of 0 are called blank numbers. We've been talking about it. They are opposite numbers. Now, try this problem. Number 9. Graph each integer and its opposite in the number line below. So the first thing I'm going to do is I'm going to graph these numbers. So the first one is 5. So I come over here on the number line, I find my 5. -1 is here, 4 is here, and -2 is here. So now we have to do their opposite. So I'm going to change colors. So for -2, we'll just start at the left and work our way right. I am 2 places from 0, so I would do opposite, which is 2 places to the right. -1 is 1 place to the left of 0, so the opposite would be 1 place to the right of 0. 4 is 4 places to the right of 0, so I'm going to go 4 places to the left of 0. 5 is 5 places to the right of 0, so I move 5 places to the left of 0, and there's my opposites. Alright, so number 10 says, look at the number lines on the previous page. There are numbers between the numbers you graphed. Just as whole numbers can be positive or negative, fractions and decimals can also be positive and negative. So the number 1½ is between 1 and 2. The number -1½ is between -2 and -1. So draw a point at 1½ and a point at -1½ on the number line. Label each point with its value. So let's start with the positive. 1½ would be halfway between 1 and 2. So it would be right here, and this would be 1.5. The opposite of that would be -1½ So we would have to go from 0 to the left. So we'd have 1, it would be same thing, located between -1 and -2. So it would go right here. And this would be -1½ So how is locating -1½ on a number line the same as locating 1½ on a number line? How is it different? Well, it's going to be just like our integers. So it is the same distance from 0, but in the opposite direction. Number 12 says, use the number line below to graph the following numbers. Label each point with its value, then graph and label the opposite of each number. So let's start by labeling these. 1½ would be halfway between 1 and 2, so that would be here. -1 1/4 is going to be halfway between -1 and -1/2, 1 1/2. So that would be here. -1/2 would be halfway between 0 and -1, so that would be here. You need to make sure that you're being careful when you're doing your negatives though, because a lot of people want to put the number before where it goes. For example, if it's 1 1/2, you know on positive 1 1/2 it would go here, but a lot of people like to look and think 1, oh, it goes halfway there, and it would go here. And that's not -1 1/2. So just be careful, make sure you're putting it in the right spot. Then our opposites would be, if -1/2 is halfway between 0 and -1, then positive 1/2 would be halfway between 0 and 1. If negative 1 1/4 is one line past the negative 1, it would be one line past the negative 1, or positive 1. And then if 1 1/2 is halfway between 1 and 2, negative 1 1/2 would be halfway between negative 1 and negative 2. Alright, so let's try it another way. We're going to do writing positive and negative numbers to represent situations. So, when you're talking about owing someone or below level or decreasing, those are all going to be negative numbers. If it's talking about going down, it's negative. If you are gaining or you are above or you are increasing or putting a credit to an account, all of those would be positives. So if we look at A, it says you owe $25. Well, if you owe somebody something, that would be a negative, so we would put negative 25. B, a team has a gain of 20 yards in a football game. Well, gain is going up, so that would be a positive 20, or you could just write 20. C, 2 floors below ground level. That's down because it's below. It would be a negative 2. 15 degrees above 0. Above would be positive, so it would be positive 15 or just 15. And then a stock price fell 4.26 points, so it would be a negative 4 and 2600ths, or 4.26. Alright, so now we're going to use what we just did on Lesson 12 and work with Lesson 13, which is still positive and negative numbers, only now we're going to talk a little bit about absolute value of these positive and negative numbers and putting them in order. So, the elevation of an object tells you its distance above or below sea level. Negative numbers are used to represent objects below sea level. Positive numbers are used to represent objects above sea level, which once again I told you previously, above is positive, below is negative. So you can see here that we have elevations. We have the mountain, which is at a positive 2, a fish is at negative 1, a sunken ship is at negative 4, and an airplane is at 4. So we're going to use what we know to solve these. Sea level is marked and labeled on the number line. Mark and label the elevation of the objects listed in the table above on the number line. So if you look above on the number line, the first one is the mountain and it is at 2. So we're just going to mark, let's say this is 1, this is 2, this would be the mountain. The second one above is the fish and it is at negative 1. So if we did negative 1, negative 2, negative 1, we would put the fish. The sunken ship is at negative 4. So we'll just kind of continue our number line down. This would be negative 3, negative 4. This would be the ship. And then at positive 4 is the airplane. So we'll just continue this up. This would be 3, this is 4, this is the airplane. Okay, it's just a vertical number line. So B says, how far above sea level is the mountain? So all we do is we count. 1, 2. So it's 2. And these are all in kilometers, so we're going to put kilometers. How far below sea level is the school of fish? Well, it would be 1 kilometers below. Is the airplane above or below sea level? Well, if this is sea level, is it above or below? It would be above. What two objects are the same distance from sea level? So, the same distance from sea level, that means they would be the same distance from 0 on both sides. Well, the only ones that have the same numbers or the opposite numbers are the airplane and the sunken ship. And how do we know this? Because they're the same distance from 0. So, explain how you could find the distance of the objects from sea level. Well, all we would have to do is count how far above or below zero it is. Alright, so let's find out more. When you answered how far each object is from sea level, you found the absolute value of a number. The absolute value of a number is its distance from zero on the number line. So, when you see these two little lines outside of an integer, a positive or a negative number, that means the absolute value of -4. So -4 is 4 units from 0, so the absolute value of -4 is 4. The absolute value of -4 is 4 because -4 is 4 units from 0 on a number line. So the absolute value represents distance, so its value is always greater than or equal to 0. So the absolute value of 0 is going to be 0. The further a number is from 0, the greater the number's absolute value. In real-world situations, the absolute value of a number is often used to describe the situation. The elevation of the fish is -1 kilometer, but you could also say that the fish is 1 kilometer below sea level. The elevation of the sunken ship is -4 kilometers, but you could also say that the sunken ship is 4 kilometers below sea level. So, look at your number line on the previous page. Which pair of numbers have the same absolute value? How are the numbers related? Well, we've already said that it was 4 and -4. And they are opposites. And they are 4 units away from 0. So, now let's compare positive and negative numbers. One morning it was -9 degrees Fahrenheit in Columbus, Ohio, and -7 degrees Fahrenheit in Pittsburgh, Pennsylvania. Was it warmer in Columbus or Pittsburgh? So, we can picture this by graphing these numbers on a number line, as you can see here. Or we can model it using the number line to write an inequality or to compare the numbers. So in this case, we're saying greater than or less than. So -9 is to the left of -7 on a number line. That means that -9 is less than -7. So we can use our symbols to show that. We could also model it using a second inequality to compare the numbers. We can say -7 is to the right of -9 on the number line. So that means that -7 is greater than -9. Both of these show the same thing, we just have the numbers and the signs flipped. So, look at the number line in the picture. Where is -9 located? It is 9 units to the left of 0. Where is -7 located? 7 units to the left of 0. So 3 says, from left to right, does the number line show numbers from least to greatest or greatest to least? So left to right, left is always negative, so it would be from least to greatest, because negative numbers are smaller. Number 4, which is the warmer temperature, -9 or -7? The further right you go, the higher the temperature, so it would be -7 degrees Fahrenheit for the warmer. Which city was warmer? It would be Pittsburgh, Pennsylvania. Number 5, model it Pennsylvania's A. Sorry about that. Model it shows that you can write two inequalities to compare -9 and -7. Write two inequalities to compare -6 and -5. How do you decide? Well, inequalities, remember, it's just comparison. It's using greater than or less than. So, if we're comparing -6 and 5, 5 is a positive number, so 5 would be bigger, so we would say -6 is less than 5. If I switched my numbers around and did 5 compared to -6, 5 is still bigger, so it would be 5 is greater than -6. How did we decide? Well, you just basically tell how you did it. Number 6, explain how you can use a number line to compare any two numbers. You graph the numbers. Then look at which number is further left. That number is less than the other number. So let's try it. Write two inequalities to compare -5 and -3. And number 8, write two inequalities to compare 9 and -9. Take a moment, pause the video, and then work them out. Okay, so number 7, it would be -5 is less than -3 because it's further to the left, or -3 is greater than -5. For number 8, we would have 9 is greater than -9, or -9 is less than 9 because -9 is to the left of 9. So we're going to continue comparing now, only now we're going to put some more numbers in there, so we have to put them in order. So we have 5 friends played a game where you earn positive and negative points. Their final scores were -3.5, 2, -3, -1, and 1.5. What was the highest score? What was the lowest score? So we can picture this and graph all the numbers and then look to see which one's further left and further right. Or we can model it and we can compare them. So we have -3.5 is to the left of -3, -3 is to the left of -1, -1 is to the left of 1.5, and 1.5 is to the left of 2. Or we can compare them in another way by looking in the opposite direction. 2 is to the right of 1.5, 1.5 is to the right of -1, -1 is to the right of -3, and -3 is to the right of -3.5. So, look at the first model it. Order the numbers from least to greatest. So we're looking at the number line, so we're going to put them in order from left to right. So in this case, we would have -3.5, -3, -1, 1.5, and 2. Look at the second model it. Order the numbers from greatest to least. So this one, we would be putting which number is further to the right. So we would start with 2, 1.5, -1, -3, -3.5. What is the lowest score? Well, our lowest score would be -3.5 because it is furthest to the left on the number line. What was the highest score, and how do you know? Well, the highest score would be 2 because it was the furthest right. On the number line. So number 13, it says, explain how to use the number line to order numbers. So we graph the numbers. Least to greatest is left to right, and greatest to least is right to left. So now I want you to take a minute, pause the video, and work out number 14 and 15 by ordering the numbers from least to greatest for 14 and ordering the numbers from greatest to least and number 15. Alright, so for A on 14, it's -8, -7, -6, -5. For B, it's -8.2, -5, -3.5, 6, and 8.2. For 15A, it would be 2, 5 fourths, -3 fourths, and -1. For B, it's 1.5, 1 and 25 hundredths, 0, -0.5, and -5. So if you have any questions, please make sure you raise your hand and ask. But now you need to go back into classroom and complete your exit ticket. Once you finish the exit ticket, then you can work on page 124 and 125, the guided practice questions, in your independent workbook.